Right, welcome back everyone. And today's presentation it should be an amazing, presentation. And I want to record this project or this presentation from a teacher directly. And the link is in the description of the video and the YouTube channel. So, hello, and before starting, I'm Jawad Rahimi, Google, a software engineer, Google Developers Scholar, an AI platform or an AI new platform for the students and students of university or other people that want to take your own project and just complete that, of course. So before we start, I'm gonna show you. I'm gonna say a real life analogy for the starting this times. Imagine you're designing innovation cars for an event, okay? And instead of creating each car from scratch, you use a pre-designed template. You simply make copies, modify a few details, or you're done. This is exactly what a prototype design pattern does. This is exactly what a prototype design pattern does. Okay, in programming, it helps us replicate existing object to save time and effort. This is all about the pre-starting or pre-brain of the understanding exactly what a design pattern is. So, and also it is the prototype design pattern, of course, and they're related to the common problem. I want to show you, or I want to say a common problem that is related to the computer science and programming, or maybe in real life. Have you ever faced a situation where creating new objects from scratch is time consuming? It does. It maybe serve a lot of time, or your creation logic is too complex. The prototype pattern, solve this by allowing us to create new object by copying existing one. You don't need to create another one. Okay, you just copy from another one. You just create from the another one from the existing one. Okay, so. But actually, today I'm gonna present a design pattern, or one of the most impractical from the creational design pattern is called prototype design pattern. So in this lecture, we have to understand what a prototype design pattern is. It is a creational design pattern that enables the cloning, of objects, ensuring that each prototypes and the structure or preserved detail depending on their specific classes. The pattern minimizes the cost of, creating new object by reducing using the instance through declining in here. But in here, I didn't mention the I didn't mention the agenda, but I want to show you the agenda. I want to set you. I want to say for the agenda what a prototype design pattern is, and then we're gonna go ahead what is work with real world examples, and also saying the advantage and disadvantage and the practical use cases for the prototype design pattern, and finally I will demonstrate it with a Dart implementation with a code by creating UML and then implementing in a Dart pattern in the Dart, ideally for a code. So let's go ahead and understand what is the benefit of the prototype design pattern. We understood the design pattern, the prototype design pattern. But the prototype design pattern is a creational design pattern that allow us to create an object from the existing one. You don't need to create another one separately, but directly just create another object from the existing one for copying. By you copying. From the existing ones, and by simplifying a lot of benefits, such as copying and pasting with some objects, or maybe in a graphic design when when you have some layer and you just use layer by layer, layer to layer, to using copy and paste, one of the most impractical of the prototype design pattern. So in here I want to show you the benefits of the prototype design pattern. It is efficiency, of course, as I said for you. It serves a lot of time. It doesn't need to serve a lot of time, to consume a lot of time, because you have to copy and paste. You have to copy and paste by creating a new object, not a new object, by creating an object from the existing one. So the second one is in resource optimization. Of course, you don't need to create another one, to serve a lot of space for your resources. And the third one is simplifying object management. Of course, when you're creating from the existing one, it's going to be very clear to manage your objects. I have a lot of, I don't need to create a lot of objects. I just have one object by creating another object from existing ones. It's also ideal for the system in needing a variety of similar objects. Instead of creating subclasses or writing redundant initialization logic, you can clone on a basic object by by creating by from the another one from the existing one, and make minor adjustment, streamline the process and reducing complexity in the code maintenance. Of course, exactly. The finally I should say, there are a lot of benefit for the for the cloning objects from the existing ones, to lower your time efficiency, to optimize your space, and also to simplify your management of the object in the OOP of your coding. So how does it work? Of course, it has three options to use the prototyping pattern in your implementation. The first one is prototype interface. Of course, it declares the clue method to interface your object. It means to create from another from existing ones. It means to create from the from the existing ones, and the concrete prototype. It is also implementing the glue method for duplicating itself, for duplicating new objects to create. You don't need to create another one. Just duplicate your object in this surface. But the last one is client initialize the prototype to create new objects. Of course, the client will initialize the prototype to create another object or the new object in here. UML diagram has three parts. For the prototype, it shows the interface of the cloning object, shows the interface for user interface for cloning objects, for creating another one from the existing one. It is the exact meaning of the cloning in the programming. But a concrete prototype, it means implements the prototype interface. When you create your interface, you just need to implement your prototype interface in here. And just the last one is the client that use the prototype to create an object in here. Of course, when we create an interface, we need to create the objects to to integrate between them. So it is the UML. There is a lot of sources here, and I'll show you for the function. It's going to be very good for this abstract data. Okay, to clone that and to create an implementation. And also the rectangle is way more than straight and like this. So the line and the catalog is also like this. So the use case complex object creation objects that are glued to create due to their size or complexity. Of course, some use case or some application of the prototype design in programming is for complex object creation. It means objects that are glued to create due to their size or complexity. Of course, when you maybe when you have some complex object creation, you have a lot of object to create, or maybe a lot of complex environment. You need to, or you have to use the cloning, and then it means in here, of course, I want to show you that cloning, and also to show you what I have in here. For example, for cloning, and also just implementing recursive time, and just decline or creating another object in here, for having a complex object creation, or for having a complex environment. And then the dynamic system memory of your objects change at runtime and need to be duplicated frequently. You just use the prototype design, for example, an environment that frequently change. Okay, that frequently change the environment in here, and just need to duplicate frequently the duplicated object. Maybe if you have the environment that is going to be duplicated in here, so you just use the the prototype design pattern. And also to the game development. In game development, we have to we just need to duplicate the object for a lot of time, because you need to create an object and duplicate it for the competition environment. Okay, to simulate the other objects in here. And also for document management. For document management, copying document template with a slight modification, just create the last part of your environment by document, to clear for all the clients to learn. So the real world example, I want to say the graphic design tools. The graphic design tools, we have a lot of graphic design that is duplicated for a lot of time, for color, for style, for duplicating shape. You create a shape and then duplicate for another shape. Okay, you just want to use some stack in your graphic design. It is also used from the prototype design pattern, because the prototype design pattern is a creation design pattern just by copying an existing ones. And when we style your some shape in here, it is going to be very useful to use the prototype design pattern for the game environment. Cloning game and creating a game object like enemies or NPCs, to compare with other objects that are existing in here. And the frameworks, most of the frameworks use prototype-based cloning of optimization performance, such as Django and also maybe Node.js and Express also maybe because they just reuse that, okay, or maybe existing from another one. Framework using prototype patterns, for example, Java libraries and object cloning or React, like this, and also design software like Photoshop or Figma is also. So this is the code, not this code exactly, but it's, code is Jar, but I'm not show you in here. Conclusion: core idea is the prototype pattern simplified and creation cloning, keeping it pace and efficiency, flexibility, and reduce resource consumption. And last one is application was using gaming design tools and dynamic systems here. They want to show you what I'm talking about. It is all about the prototype design pattern that I presented in here. So it's going to be very, very long. So I want to stop and pause the video, and for having understanding more clearly, just watch another video.